YouTube. This is Brooks Coleman, president of the Robot Group, and it's time for another episode of What's Up in Your Shop Tonight? Last time we did a little thing on the making of the desk. I'm working on a couple of different things to do the changing backgrounds, but made some headway on cutting the foam circles that will make up the columns that I've got to carve. That will get steel cast with an aluminum jacket, but had to do a bunch of chopping on metal. I got a bunch of that stuff chopped up, so that'll flow into the crucible a lot easier as the furnace melts it all down. But tonight we're going to start on a little bit about the Waycool robotic arm. Waycool 100 is this is a 3D printed version of one that I created back in the late 1980s using servos. This one's using all sorts of stepper motors here, one particular type of stepper motor, and but we're going to start out with how I'm driving all of the different parts here. And the original versions with the servos were direct drive or spooled little spool winches, and this is one of those, although it's running really badly right now. It's having all sorts of problems. We'll get into that later, but first we're going to focus on something, first step in 3D printing, something that could be valuable for really helpful in all sorts of different projects, is the tooth belts and tooth pulleys. I discovered I could 3D print little timing belts. I designed them with a gear generator. I'll show a link for that. Okay, a little bit of background on how I developed, how I made my little gears, my little gear templates in CAD. This is gear template generator, gear generator 3. I'll put a link in the body of the text there in a little bit, but yeah, basically this is a really cool little program. Okay, a real quick demo of the how to make a tooth belt using gear generator here. I've designed this 100 tooth belt there. I've turned off the grid and the center line and all that, so it's just the tooth, just the gear teeth. And I'll export that as a DFX with polylines, and I've saved that to my desktop and dragged it into TurboCAD here and got it all centered and re-ratioed. There's a ratio difference between gear generator and TurboCAD. So anyway, I've got it the right size and everything, and I want to extrude it. It's currently, let's see, just a two-dimensional polyline there. So I'm going to click on simple extrude there and click on that, and that turns the lines purple. And so I'm just going to define it as 20 millimeters high, so that gives us a three-dimensional object there. And let's see here, is that still centered? Is our polyline centered? No, we want it right at 0, Z at 0, and then I'm going to make a cylinder. We want a belt with teeth on the inside, so this is a gear with the teeth on the outside. Gear generator will produce internal gear patterns technically they're sort of, but the poly lines aren't the same from inside to out, so it ends up being the same process anyway. So I'm going to make a 100-sided cylinder there at 0 tab 0 tab 0, and then I'm going to make it just a little bit larger than the gear teeth there, and let's call this one 5 millimeters high. And are we still in the center there? Yes, we are. Okay. So what we want to do a Boolean subtract. Click on Boolean subtract over on this side, and from the disk, that prism right there, we're going to subtract the simple extrude, and there we go. A tooth belt. Printing this in flexible TPU on the 3D printer. I use a 0.4 millimeter nozzle, and gets pretty good fine detail results on my Ender 3 Pro. They're pretty robust belts. If you get the thickness just right, they don't stretch, but they still bend over a tight radius. And I've tested them. So on to the testing clips here. Yeah. Okay, timing belt test. These little tooth belts that I've been making with the flexible TPU here. I made a little mark here, that timing point there, and that little red mark there. It should be exactly the same each time that it sweeps back and forth. So I'm going to let that run. It took a while to get the drive pulley was the hardest, because when it gets the tooth belt geometry, the way I make these is doing a Boolean subtract of a gear on a disc, so that leaves the reverse there, but it's not exactly the same when you wrap it around a much smaller radius. So I had to trim the teeth narrower by doing a Boolean intersect kind of thing, putting two pulley files one on top of the other, rotating it. This ended up being, you reduce the scale by, let's see, 0.925 and rotate 4 degrees and do a Boolean intersect, and that will produce the right ratio to make it fit the tooth belt. Because when you bend it, it actually bends on the soft part between the teeth, and the teeth actually kind of spread out a little bit, so they don't want to go down in the narrower grooves of between the teeth on that. So that took a little bit of experimenting, but I got it to work. And also took a while to get just this test file on the, or test code on the Arduino, or test sketch. Took a while to adjust the parameters to get it to rotate in many revolutions to run the test here. But it's running, and I need to put stops on the shaft there and spacers to get it to line up right, but it seems to be holding together by itself, just kind of sitting there idle. But pop that down every once in a while. Anyway, and once I get it lined up, it'll stop jumping like that. But as you can see, they're still staying synchronized. So so, and you'll let that run for a while and hope everything works out. Okay, our stepper motor set up here, our tooth belt marks here are still synchronized in the right spot on the pulley, so the tooth belt and cogs here are doing their job. Even though they're not really aligned, they're staying synchronized. But that squealing sound there is a sign of trouble here. We'll see here in just a second. Let's see if it can make it on the upswing here. Yeah, we're missing steps there. That's the stepper motor. It's a little warm. Still not really hot. It's just, I think just the fact that this shaft out here is cantilevered, it's only supported on one side. It's really causing a lot of friction in that bearing there. So that seems to be the main problem there. But otherwise, the 3D printed parts, all these tooth belts and tooth pulley timing gears here seem to be working just fine. So this is way more weight than the little arm here is gonna be lifting. So that's 115 grams on a 120 millimeter radius, and this isn't going to be anywhere near as much that weight. We're about the same distance, but so I think it'll still be fine. I may go ahead and make a extra shaft end support there, so it doesn't wear out the bearings there. Otherwise, it looks to be passing the test. I even recorded the whole thing in time lapse there, and it shows exactly when it started missing steps and all that. So we're doing good. Okay, now just to recap here, we've generated a gear pattern here. We got it into TurboCAD or whatever Fusion 360 or whatever CAD program you want to use, and then we saved it as an STL file. And let's see, I'm using the standard, generic slicer program that came with my Creality Ender 3 Pro, and it's a basic little program. It works pretty good. I've got a newer version, but this is simple. It works, and so I've dragged the STL file, put it on my little platform here, and I've printing TPU is a little tricky. You got to go slow. I've got the layer height set at 0.1, shell thickness at 0.8, bottom thickness at 0.16 rather, 0.16 for bottom top thickness, and fill density 100%. And like I said, TPU you want to run really slow, so I'm running it at 28 millimeters per second and 221 degrees C with a bed temperature of 71. And sometimes I run temperature a little bit higher. You can print a little bit faster, but not too much faster than 30 millimeters per second. But if you print too high, it'll stick to the bed really bad, it'll tear up that removable magnetic sheet bed thing they use. And of course, don't need any support, no overhangs or anything for that. Not using any platform or adhesion or anything like that. No skirt or brim. And it's 1.75 millimeter filament, 100% flow, and I'm using a 0.4 millimeter nozzle. So that should get you a pretty good print. And as usual, all these new things, anytime you do something new, you're gonna have to mess with it a little bit, just kind of experiment with stuff. But this should get you a pretty good tooth belt. And for the pulleys, that's pretty simple. If you print PLA all the time, you just print it a lot faster. Same most everything, but you can get up to 60, 80, 100 millimeters per second sometimes. But I generally keep it down around 60 just to keep it stable. And the birds chirping in the distance telling me we're done with this segment. Okay, so yeah, there you go. 3D printed TPU timing belt. Generally, once you get started with these things, you can resize them, you can make them taller, narrower to fit whatever drive needs you have in mind you're working on. But basically, I'm going to post the Thingiverse page I'm setting up. I'm setting that up tonight, and I'll toss in the link to that. And then you can start printing your own and doing whatever you want with them, experimental projects. And in the next few months, I'll start refining the design on this. I'm still working the bugs out. I've been having a little bit of problem. The really nice, really thin, really fine fishing line I use for the control for the end effector is a little too stretchy, and at the moment it's stretching out even more, because I don't know if you can tell, but it's 110 in here, and there, that's about where the audio cut out. And so I've got to just voice over this end part. But yeah, to wrap things up, next time on the show we're going to work out some details on the arm there. But some other projects I've got going. I got all the parts to the CNC mill I'm working on. Finally got all that together, and it's coming along. I've got all the parts digitized or encoded or whatever. But now I'm just kind of putting them all together in the CAD system and trying to work out the design to make it all fit this thing here. This is the overall look for it. And I've got all the measurements for the metal parts I've got to cut out. Still working on how the actual table part's going to mount, but let's see, as Gator Girl stares at me here. Yeah, I guess also I might do a little bit of detail explanation of what I got going here. This is the little CNC positioning table here that I've got, using the little same servo motors as the robotic arm. But also on the 3D printed project list is to finish out the design. I've been kind of making some rough prototypes of this. This is a wearable air filter system, self-powered air filtration system. It's going to have replaceable filters and UVC sterilizer chamber in there somewhere. But the objective is make something that's pretty much all clear, so TSA won't freak out so much if you try to get in an airplane with something that's actually going to work. But also on the project list, I've been working out the parts for this thing. This is going to be a flying dive tube tower sort of thing. It's going to be tethered to the ground. I may actually tether the power, but I've already bought the motors, 8 motors and speed controllers, and a bunch of lights and plastic tubing to make a lightweight ring tube kind of thing. But that's been something I've been wanting to do for a while, making frame parts for that. Also kind of collecting parts for a flying manta ray, something that's part quad but also has forward propulsion, so it can fly really slow. It'll look like it's actually flapping its wings. It'll be flying really slow, much like they do in real life. Not trying to actually make it fly by flapping propulsion, but it'll have a forward drive. But also, want to give a big thanks to Matt Gankman and Dalton Ray Schultz for sending me a bunch of parts to a bunch of cool new quads. I've got this one together. Had some problems with the flight controller I bought. The receiver didn't work so well. It finally did bind, but it's got really lousy range. But I got a new flight controller on the way, so we'll get more fun with that. But also, last but not least, I'm going to send a bunch of these. I've been experimenting with different ways to make 3D printed products a lot faster. And one of the things I'm doing now is I print stuff that's flat. This only takes about 2 hours to print, hour and a half, or an hour, maybe less if you do it with a really fast and real thick filament and thick layers, but I like a little finer detail. But anyway, yeah, I heat it up. I print the part flat, get it off the bed, then reheat it. Started out heating it with just leaving it on the bed, but find a heat gun works best if you can just heat up one little area at a time, form it as you need, and then cool it with damp rag or something. And so I've been able to make these things pretty quick, and just working out some details. Gonna try to, this version will actually clip onto glasses, and I've got another version that just has the strings elastic, like the masks and stuff. But that's pretty much it for this show. So tune in next week or whenever I get time to put out another one of these things. Anyway, until then, this is Brooks Coleman from the Robot Group, and another episode of What's Up in Your Shop Tonight? My sidekick, Gator Girl. She's been around a while. Pretending she's watching. Anyway.